In this video, I'll be talking about conversion of number bases. So there are three ways question can be asked as regards conversion of number bases. The first is you could be asked to convert from base 10 to any other base. Second, you could be asked to convert from any other base to base 10. And thirdly, you could be asked to convert from any other base other than base 10 to any other base. So I'm going to explore these three ways that question can be set as regard conversion of number bases. Okay, let's start with how to convert from base 10 to any other base. So you know base 10 is the decimal system and that is the default way we express numbers. So how do you convert from base 10 to any other base? So let's take this example. So let's say you are asked to convert 24 in base 10 and you're asked to convert to base 6. How do you go about this? So what you're going to do is you're going to divide 24 by 6 and continue doing the division until you get to 0. So let's take a look. You divide 24 by 6 and that will give you 4. And what's the remainder? The remainder is 0. If you divide 4 by 6, that's not possible. So in this case, it means 0. You can't divide 4 by 6. But then the remainder becomes that 4. And now you stop. Once you get to 0 on this left hand side, you stop. So what then is our answer here? The answer here becomes 24 to base 10 is equal to 40. So you take the number from the bottom to the top, equals to 40 in base 6. So let's take a look at another example. So let's say you are asked to convert 135 in base 10 to base 2. So how do you go about it? So what you do here is you divide, just like you did earlier, you divide 135 by 2 and keep doing that until you get to 0. So what's 135 divided by 2? So you say 2 in 13, that's 6. 2, then you carry 1 because 2 in 13 is 6, remainder 1, so you carry 1 to 15. 2 in 15 will give you 7, remainder 1. Now 2 in 6, that's 3. 2 in 7, that's 3. The remainder is 1. 2 in 33, so you say 2 in 3, that's 1. Then you have 1 remaining. So 2 in 13, that will give you 6. And the remainder here is 1. 2 in 16, 8. Here there's no remainder. 2 in 8, that's 4. And there's no remainder. 2 in 4, that will give you 2. Then in this case, no remainder. Then 2 divided by 2 will give you 1, remainder 0. Then finally, 1 divided by 2, that is 2 in 1. That's not feasible, so you say 0. The remainder here will be 1. So we can say that 135 in base 10 is equal to, so you take the number from the bottom to the top. That's 1, 0, 0, 0, 0, 1, 1, 1 to base 2. So this is how you convert from base 10 to any other base. So let's take a look at a part. So let's solve a question from WAEC, a question related to converting from base 10 to any other base. So let's launch the WAEC app. On my left, I have a phone that I'm currently casting on my device, and I'm going to open the WAEC app. Then I'm going to go to question search. I'm going to select mathematics. Then I want to search by topic. And what's the topic that I want to search? I want to search for questions related to number bases. Okay, so in this particular case, I'm interested in question in 2012, question 4, objective question. So let's look for 2012 objective question 4. So in this case, the question says convert 35 in base 10 to a number in base 2. So let's look at how to solve this. So in this question, we are asked to let's convert 35 from base 10 to base 2. So what do? We take the 35, then we keep dividing by 2. So 35 divided by 2, that means 2 in 3, that's 1, remainder 1 here. Then 2 in 15, that will give us 7. The remainder here is 1. Then 2 is 17. In how many 2 can you find 17? That is 8, which is 16. So the remainder here will be 1. 2 in 8, 4. In this case, there is no remainder. 2 in 4, that's 2. Remainder 0. 2 in 2, that's 1. Remainder 0. And finally, 2 in 1 is 0. We can't divide 1 by 2. So the remainder here is 1. So you move from the bottom to the top. And that will give you 35 in base 10 is equal to 1,000,11 in base 2. And in this case, the answer is C. So option C is the correct answer. So that's how you convert from base 10 to base 2. So let's talk about how to convert from order base to base 10. So how do we reverse the process? So let's just take a look. So I'm going to take an example on how to convert from order base to base 10. So let's take a look at this example. So let's say we have 1, 0, 1, 1, 1 in base 2, and we're asked to convert to a number in base 10, right? So how do you go about this? So this is what you do. You take 1, 0, 1, 1, 1 in base 2, then you attach their place value, more or less like the position of each number, starting from the rightmost side to the leftmost side. So this one occupies the units, which is 0, the tens, then the hundreds, and the thousand, and so on. So it means the first step is to attach the place of each of this number. Then the next is to perform this operation. So you take this first number, which is 1, then you multiply by the base, right? Raised to the power of the place number, the position of that number. The position is 4, right? Then you say plus this next digit, which is 0, times 2, which is the base, raised to the power of the position of that 0. Then plus 1 times 2 raised to the power of the position, which is 2, plus 1 times 2 raised to the power 1, then plus 1 times 2 raised to the power of 0. So this is how you convert to base 10. So the next phase is to simplify. So how do we simplify? We say 1 times 2 raised to the power 4. So what's 2 raised to the power 4? That's 2 times 2 times 2 times 2. So that is something like this. 2 times 2 times 2 times 2. And that will give you, okay, let's just, now since you have 0 times whatever number you have here, you just take it as 0. It doesn't matter what this number is. Then plus 1 times 2 times 2, right? Then plus 1 times 2. Since you have raised to the power 1, it means just 1, 2, right? Then plus 1 times 2 raised to the power of 0 will give us 1. So any non-zero raised to the power of 0 will give you 1. So now we have 2 times 2 times 2 times 2. That will give you 16. Then plus 0, then plus 4, then you have plus 2, then plus 1. So if you add up all of this, you're going to get 16 plus 4, that's 20 plus 2, that's 22 plus 1, and that's 23 to base 10. So this is how you convert from a base other than 10 to base 10. So let's take another example, but this time around, let's take an example with a decimal number. So what if we have a decimal number? How do we handle that? So let's say we have another example. So let's say in this case, we have 1, 2, 3 in base 5. And this time around, okay, let's add decimal 1 to 3.4, right? In base 5, we want to convert to base 10. So here you have 123.4 base 5. So how do you go about it? So let's deal with the positive side. So here you have 0, 1, 2, right? Just as usual. So what happens to the decimal side? You just, as you can guess, minus 1, minus 2, minus 3, and so on. So in this case, it's just minus 1. So how do you perform this operation? The same thing. You just take the number times 5 raised to the power of the place number. So that's 1 times the base raised to the power of the place number, which is 2, plus 2 times 5 raised to the power of 1, right? Then plus 3 times 5 raised to the power of 0. Then plus, here you have 4 times 5 raised to the power of minus 1. Okay, so what do we do next? We simplify, we just evaluate this. So that's 1 times 5 times 5. 5 times 5 will give you 25. Then plus 2 times 5. 5 raised to the power 1 is 5. Then times 2, that gives you 10. Then plus 5 raised to the power of 0 is 1. 1 times 3, that gives you 3. So this is the part that is a bit interesting. So this will be 4 times 5 raised to the power minus 1 is equivalent to you saying 1 over 5, right? So this gives you 25 plus 10, that's 35, plus 3, that's 38. Then plus 4 over 5. So 4 over 5 will give you 0.8. Use your calculator, that will give you 0.8. Then if you add everything up, you're going to get 38.8 in base 10. So this is how you convert from other base to a number in base 10. So let's take an example from past question. Let's take a look at an example from WAEC question. Let's solve a question from WAS 2005. So we're going to look at question number 11 of WAS 2005. So let's search for it. So 2005 question 11. So that's this. So in this question, we're asked to convert 101101 in base 2 to a number in base 10. So how do we solve this? So let's take a look at the solution. So let's solve this question. 101101 in base 2, 1 converts to a number in base 10. So you first assign the place number. This is 0, this is 1, this is 2, 3, 4, and 5. So what do you do here? You take the first number here, which is 1, times 2 raised to the power of 5, then plus 0 times 2 raised to the power of 4, plus 1 times 2 raised to the power of 3, plus 1 times 2 raised to the power of 2, plus 0 times 2 raised to the power of 1, plus 1 times 2 raised to the power of 0. So if you simplify this, you arrive at 2 raised to the power of 5, that's 32, then 0 times whatever you have here, that's 0, then plus 1 times 2 raised to the power of 3, what's 2 raised to the power of 3? That will give you 8, then plus 2 raised to the power of 2, that's 4, plus 0 times 2, that will give you 0, then 1 times 1, 2 raised to the power of 0 is 1, so that gives you 1. So let's add this up. So 32 plus 8, that's 40. 40 plus 4, that's 44. Then plus 1, that's 45 in base 10. So in this case, the right option is option C. So we talked about converting from another base to base 10. So what about converting from one base that is not base 10 to another base that is not base 10? So let's take a look at this example. So let's say we are told to convert a number like this 1, 2, 1 in base 3. We're told to convert to base 5, for instance. So how do we go about this? So what you do here is you convert 1 to 1 in base 3, you first convert to base 10, to a number in base 10. Then whatever you get in base 10, you convert to a number in base 5. So you perform two operations. You first convert to base 10, then from base 10, you convert to that other base, which is base 5. So let's take a look at how to go about this. You have 1 2 1 in base 3, and now we want to convert to base 10. So how do you go about it? You can recall that the first thing you do is to add the place number. This is 0, this is 1, and this is 2. So you say 1 times 3 raised to the power of 2 plus 2 times the base, which is 3, raised to the power of 1, plus 1 times 3 raised to the power of 0, which is the place number. So you simplify this, that gives you 1 times 3 raised to the power of 2 is 9, so this is 9. Then this is 2 times 3, that gives you 6. Then this is 1 times 1, 3 raised to the power of 0 is 1. And if you add this up, you get 16. So it means we need to this 16 in base 10. So the next phase is to convert 16 in base 10 to base 5. So you can recall that to convert from base 10 to another base, you divide. So you take the 16, right? Then you keep dividing by 5. So you say 5 in 16, that will give you 3. And that's 15, right? So the remainder here is 1. Then 5 in 3, that's not feasible, so you say 0, and the remainder here is 3. So we can now say that 1 to 1 in base 3 is equal to 16 in base 10, which is equal to 31 in base 5. So this is how you convert from any other base to any other base. So you first convert to base 10 before you convert to the other base. Let's take a look at an example from UTME past question. We are going to let's search for the question. So you select maths, then you want to search by topic, and this time around you want to search for question related to number bases. Then you search and then you have the suggestion. So in this case, we are interested in 2006 question 26. So the question says that we should convert 2232 in base 4 to a number in base 6. So let's take a look at how to solve this particular question. So you have 2232 in base 4. So the first thing we'll do is to convert to base 10, then convert to base 6. So let's convert to base 10. So 2232 rather in base 4 To convert to base 10, you first add the place number. This is 0, 1, 2, and 3. So you say 2 times 4 raised to the power of 3 plus 2 times 4 raised to the power of 2 plus 3 times 4 raised to the power of 1 plus 2 times 4 raised to the power of 0. If you simplify this, you're going to get 2 times 4 raised to the power of 3. So what's 4 raised to the power of 3? That is going to give you 60. That's going to give you 64. Then if you multiply 64 by 2, that will give you 128. Then this is 16. That's 4 raised to the power of 2. 16 times 2. That will give you 32. Then plus 3 times 4, right? That will give you 12. Then plus 2 times 0, 1. 4 raised to the power of 0 is 1. That's 2. 2 times 1 will give you 2. So if you add everything up, that will give you 128 plus 32. That gives 160, right? So 160 plus 12, that's 172 plus 2, that's 174. And this is in base 10. So we convert from base 10, right, to base 6, which is the next phase. So 17, 6 is 17. That will give us 2, that's 12. So if you subtract 12 from 17, the remainder will be 5. So you have 5 here. So 6 in 54 will give us 9, remainder 0. So there's no remainder in this case. So now you have 6 in 29. That's, if you divide, that will give us 4, right? And the remainder will be, 4 times 6, that's 24. If you subtract 24 from 29, the remainder will be 5, right? Then 6 in 4, that's not feasible, so you write 0 and you carry everything as the remainder, which is 4. So what then is the answer? The answer is 2, 2, 3, 2 in base 4 is equal to 174 in base 10, which is equal to 450 in base 6. So let's see what the right answer is. So the right answer is option A, which is 450 in base 6. So this is basically how you convert from one base that is not base 10 to another base that is not base 10. So this is basically how you convert from one base to another base. So the next topic I want to talk about is multiplication and division of number bases.